Can you see my new screen? The spectrum? Hello?
Yes.
Yeah. Thank you very much. I have processed it already. But yeah, I think you can see it's just okay. I think I'll have to get rid of this. Just for the sake of clarity, delete all. Now, let us expand it and expand, because I'm talking of the 2-glucose, we come to this region. There we have, yeah. Expand this. Now, from the proton spectrum, you can calculate the J values, this one, this one, this one, this one. I told you last time. Just do this, come here. This symbol, it looks like J. And I like doing it manually. And then click on it and report multiply. 5.8, J value 8.3. Now, sorry about that. We have another proton. It's around 6 point something. Yeah, this too belongs to that sugar. J already given there, 2. Now, whenever you have a sugar molecule in your compound and you see the J value, that is the J value assignable to the anomeric proton is this small, below 2, 2 point something, that is small. Then that tells you that the protons in that glucose unit are in equatorial conformation with reference to the planar structure of the sugar. Whenever the J value is bigger, 7 point something, the protons are actually oriented. Now, let us see what I'm talking about in form of a figure. How do we draw that? What does it mean? Equatorial. Actual. When we know how do we draw them? Can draw true. From my own experience, whenever you realize that the spectrum is revealing to you about the presence of sugar units in a molecule, draw them first. Because sugar is very easy, And then after drawing the sugar, then check your HMBC and find out if there are any correlations between some of the hydroxy groups of the sugar and any other thing within that compound. Then from there, you can start moving, progressing from one stage to the other, from one stage to the other. Now, in the case of this particular compound, if you start from sugar units, it will help you. You will have to get somewhere. New share, ChemDraw. Can you see my screen? Are they big enough? Magnify.
Yes.
Yes, we can see it.
Thank you
Yeah,
very
it's bigger.
much.
It's bigger now. Yes.
Yeah. Now, what you have before you, these are glucose units, the chair conformation, two forms of the chair conformation of glucose units. This one here, to begin with, if you don't know about the numbering, this is glucose 1. So when you hear me talking about the anomeric proton, I'm talking about the proton here. It is silent, you don't see it. This proton attached to this carbon number 1. This proton, number 1, 2, carbon 1, carbon 2, carbon 3, carbon number 4, carbon number 5, carbon number 6. If you're not familiar with, the values, carbon 13 chemical shift, usually carbon number 1 has got the largest value because of the oxygen here and the hydroxy group. It comes around, usually, let me say above 90, 100, 1 or something, 102. Yes. And then this 2 is small, but this is always the small. I mean, in this ring, this is the smallest form. But carbon number 6 overall is the smallest, CH2OH, around 60 something, 61, 60, 63. This one comes around 77. Usually 5 and 3 are always the largest ones. Sometimes 3 could be larger than 5. Sometimes 5 is larger than 3. Yes. And then, let me say, largest, followed by this guy here, number 3, followed by this, and that is the smallest in this. But just know that one overall is the largest. That is obvious. Yes, this one might confuse you, but 1 cannot confuse you. 1 and 6 cannot confuse you. 6 is the smallest overall. 1 is the largest overall. Then if you follow proton, COSI, you can get this one. Sometimes you get this one too. Sometimes due to overlapping signals, you rarely see these two. But if you have you're struggling between this and this, which one belongs to carbon 3, which one belongs to carbon 5? Then you can also check HMBC. Check the protons of carbon number 6. Do they correlate? I mean, which value do they correlate with in the HMBC? Because these protons will not correlate with this carbon. It is very far away. But you will see this carbon and this one, and 4, carbon 5 and carbon 4. 4 and 5 are easy to differentiate because 4 is usually smaller than 5, unless there is a substitution. I mean, if there is a substitution here, such that this one is linked to something else, or this one, or this one, then you'll see the chemical shift becoming larger. Yes. So let's go back to our tannin. There are 2 glucose units. One draw it this way. We call it 4C1 formation. It's always the most stable than this. Now, in this one, the protons are actual, like vertical. Let me say like vertical. So the proton one here always has a larger chemical shift, above 7. When you see that, then you just automatically conclude that no, this glucose is drawn this way. It takes this form. This one, proton number 1, the chemical shift, the J value is very, very small, around 2. When you see that, then automatically get to know that this one is 1C4 form of the chair conformation. The protons are equatorial along, like I can say horizontal with reference to this, or the hydroxy groups. The protons lie horizontally. Can do this and say proton. Sorry. Proton. Yes, there are reasons, the papers that have been published that try to explain why, when sometimes the hydroxy group of carbon 3 or 6 are isolated by the gallol groups, then some oxidative reactions take place that makes this glucose to change its conformation from this to this. Yes, so you may read that one and may share with you if you need some articles like that. Now, let's go back to our structure. I promise it will be a very short discussion, and then we'll take a few questions if there are, and we'll call it a day. This looks too big. 200. Can you see my screen clearly? Are we together?
Yes, we can see it.
Thank you, moderator. Thank you. Yeah, give me some feedback. That is very powerful. Yes. Now, these are our 2 glucose units drawn like this based on the J value as displayed on our proton spectrum. Now, usually when you're dealing with a tannin where the hydroxy groups of the glucose have been acetylated, as you can see, we have our gallol there, gallol here. It is very easy to follow the leading of HMBC from the chemical shift values of the protons. If you follow where this proton is on HMBC and then look what carbon does it correlate with, you will see this. You'll see this. You may see this too, but these are not important to us now because already we've done the glucose. Now we want to move out. We want to gain territory. We are moving out. What more relative do you have around here? What more ground can we gain? Then you move from this proton and check HMBC. We can do that now. Yes, let me look at the value of this proton. That's proton number 2. Proton number 2. Not that one. May I ask, are we familiar with the spectral data? I know our moderator is in social sciences. This doesn't apply to him, but to those of us, the rest of us who are viewing this presentation, how many of you are familiar with this kind of work? Hello? I mean, I'm familiar with it.
Hello,
I'm not familiar.
I'm not familiar. I'm not familiar.
You're not familiar.
Yeah.
How many are in this kind of field of study? Medicinal chemistry, organic chemistry, natural products chemistry. None of you, seems. Hello? Wow. Is this someone by the name? Yes? Hello?
I'm into medicinal chemistry.
You're in this field of study, right?
Hello.
Hello?
I'm in.
You may type, you may send a message. Yes, so I don't assume, so I don't ignore, Actually, the main purpose of this presentation is meant to edify, to try and enlighten some of us in this field. Younger ones, probably in their master's degree, or young PhDs that want to understand structure elucidation. That's why we started this. Yes, so yes. Yeah, so if you're not familiar with this and you're here, it's okay. We accommodate you, it is all right. Yes. But next time, if you know of someone who is in natural products chemistry, we also call it natural pharmaceutical chemistry or medicinal chemistry, then this kind of presentation will be so beneficial to them because those are the people we want to reach out to. So when I talk about glucose moiety, the gallol groups, the hydroxy groups, oxygen linkage, they understand the terminology, they benefit, Yes, so it is all right, we can continue. But if there's anything you don't understand and you don't have the right chemist terminologies to ask the question, it doesn't matter, just ask. We are able to understand if we can understand, and we will help one another move forward. Thank you very much.
So, Dr. Kanda, are you
Yes,
done
sir.
with your presentation?
Not yet done.
Oh, okay,
Yeah,
all right.
we're still moving. We're just starting.
Okay.
Yeah.
I thought you were kind of asking questions.
No, not yet.
Okay, thank you.
I just wanted to know about the audience. So, yes.
Okay, all right.
So I can be careful about my language.
All right, sir. All right.
Yes. Okay. So even without going to, the finer details of knowing the value of this proton here, the chemical shift value, this and that, I said, first of all, put your glucose together. There are two. Then assign each carbon atom the corresponding value from HSQC, and then begin to expand your territory as you're being led and guided by HMBC. Because if you look at the structure before you, proton COSI spectrum is only useful when drawing the glucose units. When you're done with the glucose, the proton becomes, the proton COSI becomes, let us say, useless, but you can just abandon it, because the things that we have here, you need HMBC spectrum. You've assigned already proton 1. I mean, you know it. Maybe it is 4.3. Then you check your HMBC spectrum. This proton, what else does it correlate with but is not part of the glucose unit? Unit A, Unit B, Unit A, Unit B. Glucose 1 of Unit B is glucose 1 of Unit B, 6.36. Let me just share this with you, so you may also be part of what I'm talking about here. Share, new share. So I'll do this one and this one. Now, can you see that Word document? Can you see it clearly? Can you see my Word document? Moderator?
Yes.
No,
No.
not yet.
Not
Oh,
yet.
not yet.
Not yet?
Yes, it's kind of blank. It's black.
Oh,
You post
We
your
will come
screen.
to a few minutes.
what is happening? Can you see the word now?
Yes. Yes, it's on now.
Yes,
Word.
yes. Okay.
That's kind of PDF, right? PDF.
No, not PDF.
I
It's a
think
Word document. It's a Word document.
Okay, it's a Word document, right? Okay.
It's Word, okay? Now this, can you see table 1? Highlighted
no.
in red.
Sorry,
What
this
you
is
are seeing-
PDF.
You are
It's
seeing is
PDF.
PDF.
No, I
Or
think
what
it's
you can see
PDF.
is the PDF.
Yes.
Sorry.
Okay. Which one can you see now?
Yes. Yes.
The Word document now. Yes.
We can see
the
them.
And you can see the
Table
one.
one.
Thank you very much.
Yes,
Now
it's
our glucose values from carbon 1 to 6 is unit A. Let me highlight it, just yellow. And unit B assigned clearly here. So you can see the anemonic proton of glucose unit B, 6.36, J value is 2, This one is 5.81. J value is 9. And then we have as follows. Yes, so you can then start, moving from each carbon to the next, like carbon number 1, 2, 3, 4. Carbon number 1. Does it correlate with any other? Proton 1 of glucose. Does it correlate with any other carbon? Let us check our HMPC. This is value 6.36. So we are going straight to HMPC and direct to proton 6.36. Share, Mr. Nova, share. Can you see my Mr. Nova? Hello, can you see my Mr. Nova? Moderator?
Yes. Yes.
Something with some red spots in it, right?
Yes. Yes. Some kind of dots.
Exactly. Thank you very much.
Yellow
All
dot.
right.
Thank you. Where is 6.36? This is the proton, 6.36. You can expand. Okay, to expand, if you don't know how I got there, there's a plus here, okay? A plus here, then minus, and then it stands for full spectrum. So plus, then just do that. It is now expanded. This is the proton, 6.36. You can see it correlates with this other carbon, but these carbons are on the glucose. And then there's a carbon down here. What value should it appear in around 165.4? So it means glucose 1. Yes, the hydroxy group, glucose unit B, that is carbon number 1, was hydrolyzed by the gallol groups. 165 points. And the value itself tells you it is carboxylic group, COOH. That is why you see in our structure, let me share again. New share. ChemDraw. You see, this is glucose 1. You see, proton 1, 6.36, showed correlation with 165. This value is 165.4. So you draw it this way. Already the glucose has got hydroxy here. I'm talking about this one here. Then when you introduce substitution, then it means the proton is knocked out. Then you link it to this guy here. Yes. And this guy, it is coming from this gallol group. So you bring an entire gallol group to that. But now you don't know whether it belongs to a gallol group or not. So you come here, you draw it there. Yeah, I'm proceeding, and we know there's a linkage there because carbon is connected to 4 bonds. Then this is O. And there is something beyond this. We don't know what it is. But you know, in your mind, that if what is hiding on this side has got a proton, then probably that proton correlates with this carbon also. Already, the proton of glucose 1 has led us to this. But this one, if you want to move from here to the next, then it's like doing reverse. Then you assume, you know that there is something here. And it has some protons. Is there any other proton in a HMBC spectrum that will show us correlation with this carbon? And you know the value of this carbon. So what I usually do, go to HMBC spectrum. Let me share. You know that don't forget about the value of that carbon, the chemical shift, because we need it to find that proton. And then we will need the proton we are looking for to find other carbon signals that are assignable to that Galil group, that benzene ring. So, unit B7 prime, the value there is 165.7. Now, let me just share with you my Demystification Nova once again. We are back to HMB spectrum. We know 165. 165. We go to somewhere. Now, remember, when I was looking for 165 initially, I began from the proton and I moved downwards to find that carbon. It was 6.36. It was here. The carbon, but I don't know the protons. And I found this 165. It was 165. Nice. 7 to be exact. We have this proton 7.09. Already we got this one. This proton, what could it be? This guy, but because of overlapping signals, we can expand again. Yes, so we can. This one, 7.08. And from the proton spectrum, yeah, we never said this, we never discussed this, but from the proton spectrum, we know usually when you have this, you can expand. You can see singlets. These broad singlets, they belong to the Galoil groups. Already, we found out that this proton is the one that belongs to that gargle group attached to carbon number 1 of glucose based on HMBC spectrum. And remember, let me share screen again. ChemDraw, share. This is how we draw the gargle group. You have 2 protons here, identical. If this is 2.1, this 2 is 2.1. Now, you need this proton to identify this value, this value, this value. But remember, this one and this are identical. It is symmetric. So when you have found this one, this proton, you will get the value of carbon 1 prime, the chemical shift value of that. And you lead it to this, and this. So once you've gotten, usually you'll find that this one is larger than this. So you'll find this proton correlating with this carbon, this carbon, this carbon. Because this and this are the same. So once you find one, and that one, just fix it automatically. This one is so easy because in this ring, this is the smallest. Why? It is carbon to carbon linkage. Carbon to carbon linkage. There's carbon here. So it has a smaller value, chemical shift value. You'll say it is upward shifted. This is more downward shifted than this. Yes. So already you can assign this easily. Then you move forward. You check again, following each and every glucose unit, the chemical shifts. And you will find that the values when these carbons will be larger compared to glucose, which has not been hydrolyzed by the gargle groups and the HHDP. Again, this proton will lead you to this guy. And when you get this guy, then you start looking for this proton from this guy. So which are the protons correlate to this? You get the protons there, and then this proton will lead you to these other carbon signals. But remember, this one you have single proton, only one proton. You may not get this. You may not see a correlation with this. This is far away, you know. If you have a proton here, you have J1, J2, J3 is quite far. So you will likely get this one, these two, and then this guy and this guy. You may not see this. So you leave it pending for some time. After you've assigned all the carbon chemical shifts, you will find some carbons remaining because you could not find them using proton spectrum. But then based on the values, you can say, no, this one should be here. Then, you know, that now is an assumption. But it's a good assumption, you know, because you can know based on the chemical shifts, the large one should be here, the small one should be here. What you see here, this one, we call it HHDP. Let me highlight, just highlight maybe. That color is not good. Let me try blue. Okay, yeah. Not this HHDP group. They only have 2 protons. One proton here, another proton here. Remember, the gargle groups, you have 2 protons. 1 and 2, and there's symmetry. Usually, when you want to know that there's symmetry somewhere, if you check and find out that this proton, from HSQC, you know which proton corresponds to which carbon. So let's say, for example, that the carbon here, let me just guess something. Let me say 126.7. Let me just put that on there. If this carbon is 126.7, if this is a galloid, then it means this carbon 2 is 126.7. But then from HMBC, you will see that the proton belonging to this carbon 126.7 correlates with itself, correlates with the same carbon. Usually you expect a proton of one particular carbon to correlate with other members in the same group, in the same environment. But then you'll see this proton of 126.7 showing correlations with 126.7, meaning you have another 126.7 on the other side. You are dealing with a symmetric compound, and therefore we have a galloil. This 2 belongs to this carbon. This is the same, identical to this. This is on its own, it's not identical to anything. So that's how we get to know, we get to differentiate the galloils and HHDP. There's a linkage here. If you check carefully, find that these two, this carbon-carbon linkage, they have the smallest chemical shift values compared to this hydroxy, the ones linked to hydroxy groups. Yes. So from this proton, you can easily find this and this and this and this. Then you move again to one sugar. In this case, you have carbon number 6. This is CH2. Usually, when the CH2 of glucose, when the hydroxy group here is substituted, is linked to something else, then the CH2 is shifted downwards, meaning it is larger. Normally, when you have a free hydroxy group here, we call it a free hydroxy group. Like this is a free hydroxy, free, not linked to anything. So it is free. Chemical shifts around 61, 62, 63, that is too much. When it is linked, you'll find appearing 67, 69, sometimes 70, and so no, there is a linkage. It is linked to something. Then you will find the protons. Here there are 2 protons showing correlation with this.
Hello, sir. Hello?
Is it networking problem or?
Yes, I think so. Can you hear me?
I can hear your words.
Okay. And other participants, please, can you hear?
Correlated
Okay.
with, come up. Moderator, I heard you.
Okay, no problem. We can continue, sir.
Thank you. Thank you.
All right, sir.
Yes. This carbon is quite larger. Quite larger. Meaning, I mean, it suggested, let me not say meaning, let me use the right chemistry language. It suggested that there is a link because this is a known compound. We know it. Additionally, the known compound, the chemical shift are always, the difference is not much. Even if you use different solvents, run them in NMR, difference is not much. But there was a significant shift in the carbon chemical shift assignable to this position. And we realized that, no, based on this, it indicated a linkage. Then you just put a thing there, oxygen, and fix it to this one, and you have your structure. But that is not the final. It's not the confirmation. You have to do what you call mass. You find the mass, high resolution. It indicated that indeed our structure was a mass of this and this combined. So if you approach the tannins from sugar units, and then each sugar unit will navigate you through other rooms where we have other members of the same group, put them together, you will come up with this compound. So, like I said before, I'm sharing my experiences with you, with what worked for me. It may not work for you, but at least I know you may have another way which might be better. But now this is just a foundation. You have one way which might be of some use to you in future when you encounter such problems before you. So I'll stop there and I will take questions if they are. And I'll try to answer to the best of my knowledge. Whatever I cannot answer to your satisfaction, just bear with me. But I will also like, a situation whereby if a member within the audience feels that he has something to add, to contribute to the discussion, to edify the members, including the presenter himself, feel free to say something for the benefit of all of us. We are learning. Thank you very much and welcome. Just before I invite you, any member that has a specific problem with the structure elucidation, because probably some of the compounds you are dealing with have not been, addressed here, then feel free to share with me privately. Then we can customize the presentation alone, one-on-one, any time of the day, any moment of the week, whenever you feel like. We can talk. We don't have to get to know each other before we can handle these problems. Yeah, so whenever you have a problem related to my field of study, we can always discuss, and together we shall become stronger. Thank you very much. I welcome you to bring your questions, your contributions, your suggestions, your comments. anything you feel like for improvement and towards improvement of such a presentation, just share with us. Thank you.
Thank you so much. Thank you very much, Dr. Kaunda. We are really grateful for the presentation. And it's time for a question and answer now. So please, members of OAAD, please kindly signify if you have any question or maybe any suggestion, clarification, addition or subtraction of what Dr. Kanda has just presented. Thank you so much. We look forward to hearing from you. In the group, Dr. Myra said, can you send us this article, please?
Is it possible to use this chat to send it? I'm not familiar with this app. This whatever 10-cent meeting. Is it possible?
Can if it's sent on the WeChat group, would that be okay?
Let me send it to you. Let me send to you on which I know the WeChat group of our whatever OAD.
Yes, exactly.
Okay. Thank you. And I do so right away.
Okay. Any other question, please? Dr. Larry.
Yeah, I don't have a question. I just want to say thank you to Doctor for the wonderful presentation. Like I said, I'm not familiar with this field, but I know I will be dealing with this maybe at the later stage of my research. So I believe the little introduction I acquired this evening will go a long way in helping me when I begin to study more on it. Thank you for the presentation.
Okay.
Welcome.
Thank you.
Welcome,
Thank you,
my
sir.
brother. Welcome.
And Dr. Umit.
Thank you very much giving me this opportunity to show this. I'm just starting learn that measures, so I don't have any question right now. But thank you very much. I really like this one. Thank you very much.
Okay. Thank you, sir. And how about Dr. Saliu? Dr. Ayo said the voice of Dr. Kaunda is quite low. So I think maybe it's from his or her phone. So because it's very loud here. If not, I'm very sure she would have had one or two things to say. Then Dr. Zaki.
Sir?
Yeah.
Hello, sir.
Hello, sir.
Yes, sir.
I really appreciate the presenter. He did a good job. Thanks so much, sir. We appreciate, sir.
Okay, sir. Thank you so much. Thank you so much. Yes. And Dr. Tosin is here. I don't know if you have one or two questions. Okay. So there is no question. So I think up to this moment, we are clear on Dr. Kaunda's presentation. So I would like to say a very big thank you to Dr. Kaunda. Yes, your contribution to OAAD and to Africa as a whole is very, very much appreciable. Thank you so much. Thank you so much. So, and if there is no any other thing to talk about, so maybe we would like to call it a day.
Yeah.
Hello, yeah, I'd like to just make a comment.
Oh, okay. All right then.
Yes. Thank you so much,
The President.
Dr. Olayemi, for moderating the webinar. And thank you to other participants that have come to join. And very much thanks also to our resource person who has taken our time all this while to provide content for the people that have shown interest thus far. It's been very useful, and we're always pleased to hear how beneficial these things have been to people who may have spent so much time looking for solution elsewhere if it was not provided here. We are happy to be part of the research life of many Africans, and we hope that just as Dr. Kaunda has mentioned, that subsequently any challenges around this field, we can always have a reserve of experts that can engage and support one another. So thank you so much, everyone, for participating. And Dr. Kaunda, we'll still keep taking this forward and see how much we can do around it. And possibly, if we could have some form of review or something, some research in this field that could contribute to utilization or exploration of the medicinal plants and the active ingredients or compounds that may be contained in them, that are of African origin. So that's something I hope that we could look into subsequently. Of course, that will be, it could be a project that could be handled by the Natural Product Research Group. And it's good that Ayo is here, and hopefully it's something that could be pursued subsequently within the group. So with that, I would hand over back to the moderator. Thank you so much. Thank you so much.
Thank you, Mr. President. Thank you for the comments. Thank you so much. Yes.
You're welcome.
Yeah, I would like to say good night to everybody. Once again, thank you so much for coming around. Thank you for creating your time. We are grateful. And the recording, I mean, after we have done some editing, we will be sending it to all our social media platform, and we will notify the members in the WeChat groups in case if there is anybody who would like to revisit the presentation for some practicals and maybe to have a try. Thank you so much. Have a lovely night rest.
Thank you very much. Good night,
Yes.
everyone.
Good night.
Yeah, good night. Bye-bye.
Yes, good night.
Yeah. Goodbye, everyone.
Good night.
Dr. Kaunda, thank you again.
Thank you.
Welcome, my brother. Welcome.